Welcome all. Thanks for joining today's video. In this Hydronic distribution system understanding series, we are discussing what all kind of methodologies anyone can adapt in contributing the best efficiency in the hydraulic pumping for any HVAC and R system. In my previous videos, which are available in the air conditioning playlist, you would have seen what all methodologies somebody can really adapt to select a constant or a variable primary system. In this particular video, we are going to detail out what primary variable system is all about and how it can contribute in terms of efficiency. So let's start. In the variable flow chill water system, it is the most efficient way and contributes to a great saving potential for any HVAC and R system. It can contribute in maintaining the system balancing. It can contribute in terms of significant pumping energy saving. In this video, we are going to understand the impact of variable flow through the evaporator, energy saving potentials of distributed pumping system in central AC plant, best practices for balancing of variable flow system, causes and consequences of low delta syndrome in HVAC and R plant, method of interconnect multiple chiller plant to improve the efficiency and redundancy. This is a primary variable flow system or configuration wherein you will see over here, there is a pump which is pumping water to the chiller. The water is gaining the heat and it is reducing the temperature and pumping the lowered water temperature into the system towards the load. This is the best efficient solution wherein the issue can arise if control of the chiller and the wall control are not in tandem. There is a great possibility that flow of the chiller has been reduced, but parallelly the chiller is not controlling the flow accordingly. So control of the chiller has to be taken into the consideration while designing any primary variable system. So it is a kind of modern control that accounts for the rate at which leaving chill water temperature drops. So we have to ensure while buying the chiller for any primary variable system application. We also need to ensure, try to avoid the laminar flow in the evaporator. At least 3 feet per second is recommended to maintain the good heat transfer in any chill water evaporator. So with 2-pass or 3-pass selections, what kind of variability I can get, I also need to check with the chiller supplier. Taking into consideration with 2-pass system, I can go up to 50% of the designed flow in the variable flow application. Vis-a-vis for a 3-pass evaporator, I can go even up to 30% of the design conditions. So I need to make a choice. I need to select 2-pass or a 3-pass evaporator for my application based on the variability of the load. Let's talk about only primary variable flow. Primary variable flow system have many advantages over the primary and secondary flow design. It is the simplest way of configuration which gives immense potential of energy saving. So in this you can see there is a load end and there is a chiller. Between load and chiller there is going to be a bypass flow which is going to ensure that minimum flow to the chiller is going to be maintained if there is a less load in the network. In the primary variable system, instead of three-way valve, system requires two-way control valves to modulate the flow and ensure the best efficiency can be achieved. The bypass valve also requires, it has to be a differently configured. It requires, because if there is going to be less load, bypass line over here is going to experience the more pressure drop. So it has to be pressure independent valve. Here you can see the delta P across the valve is going to be fixed across the different flow are required for the bypass. So there are few criterias and pointers while selecting the bypass valve for primary variable system. One, it has to be size less than the full pump design pressure drop across the system. It has to be designed for minimum load requirement of the cooling as well. Instead of selecting it for the same header size or the pipe size, I can go for less than the full pump design pressure. The second is the pressure independent valve is a good option. We know it is expensive, but it has excellent control authority over a wide range of operating pressures. There are many suppliers which are available in the market, those who are good for the pressure independent control valves. Let's move. Simplest configuration is single chiller with multiple cooling coils. In the primary variable system, a single chiller is going to be connected with the multiple cooling coil load. All these cooling coils are connected to the two-way valves. This is 1, this is 2 across the coil A. Here it is going to be a pressure independent two-way valve which is going to be integrated with the flow meter. This flow meter is going to be installed to ensure my chiller is going to be get minimum flow of 50%, 30% or 25% for which it is designed during the low load conditions. So this is how it operates and gives the best efficiency. If my pump is variable, if load is less over here, I will experience the higher pressure drop across here and the feedback will go to the pump to reduce the pump speed, and pump will reduce its speed and flow to ensure the chiller is going to maintain and operated with the minimum flow requirement. Now let's understand if there are multiple chillers and multiple coils into the system. These are the two chillers, two pumps, two pumps and two cooling loads. Each and every coils is again integrated with two-way valves, similar like the previous case. Here you will see a big difference. It is always recommended to have the bypass line near to the chiller room or the chillers. It will reduce the excess pressure drop in the network when system is working on the minimum or the part load or the less load. Water is not going to be, I can even provide over here also, but excessively pump is going to put the pressure and consuming energy to overcome the frictional losses over the network. If it is installed over here, this is the shortest and the closest loop and going to add a great energy efficiency into the system. It can be configured while operating the system at full load. Both of these chillers are operating for the cooling load. When load reduces, one chiller can go off below 50% of the load, and if load further reduces, the second chiller can go on the minimum flow, and the bypass valve can take the feedback from the flow meter and accordingly can ensure the minimum flow which is required to operate the chiller without any trouble. So it is always better locating it, the bypass line close to the chiller provides the best energy performance for multiple chillers with multiple cooling loads. Hope you have enjoyed this particular video. Requesting everyone to subscribe my channel, click on the bell button. In the next video, we are going to discuss primary fix and the secondary variable flow. So wait for the next video. Thank you.